Okay, so I think some other people would be joining, but let's get start the session. The first uh, some seconds or some minutes will be covering the recap part. So till that time they can join. Okay, so uh, from yesterday onwards we have started learning the business intelligence process. I think we have already have the idea what is business intelligence and why data engineers are required in business intelligence and what are the purpose of business intelligence, how they are helpful for each of the business to increase their revenue or to accelerate their growth and all. So those are the thing needs to be used business intelligence, and a part is data engineering that can be helpful to achieve their goals and all. Okay, so though all the things we have learned how the data can be stored from meaningless data to meaningful data into data warehouse, and how based on the subject area we can split it into various data marts and all. Okay, so inside data marts the particular data can be stored into fact and dimension structure. Okay, we have told the thing. So what we can do with the fact the structure in the next level means reporting level. So when we are moving everything into reporting level, before that we have to create the data modeling. So we'll be learning today what is data modeling, and we'll be learning some more features about fact and dimension. Okay, fact and dimension are the table that we have to maintain at the data warehouse or data mart level. It should be in database. Whatever database we have learned in the last week chapters, SQLs and all, those kind of performance, or those kind of thing we need to perform while creating the data marts tables, fact tables, those stuffs. Okay. Any doubt? Whatever we have learned for yesterday? Nothing. Okay, fine. So just quick recap: what is fact and what is dimension. Then we'll be quickly catch up the new things. So this is the repeating one for fact and dimension. Fact is the column, or fact is the value which contains, if we just questions on top of data how much or how many, the numerical value or measures value, those are called fact. Okay, so the example of fact should be revenue, cost, number of accounts, those are the thing. Now when we can declare the DDL of fact table. Okay, let me maximize the screen. Okay, so we should be seeing, those are the numerical columns available, and with these numerical columns, we need to also put the foreign keys from the dimension table. Okay, by consisting the keys and the fact information, it is told it's a fact table. Same thing for dimension. Dimension is not exactly the numerical value. Rather, suppose we have the product dimension. In product dimension, we should be having one primary key that is called product ID. And after that, each of the ID, the row should be signifies as product name, product brand, product hierarchy level code. So this kind of stuffs, we can check it as a product level dimension. Okay, a quick example, maybe customer table, dimension table. Store table and product table. The first one is the primary key, and the other column signifies about the store, where it's located, what is the things been sold by the store. Those are the thing. Okay, for the product as well, you can see there is no such numerical value, but they are very much important. So a quick thing, product, the dimension table is not changing daily basis because we are stored information. Suppose there is no such changes for a store, no store is getting generated daily basis. Okay, so suppose I am the owner of stores, a particular brand. It is having multiple outlets for multiple cities. I have 44 outlets. Okay, so for each of the outlets a particular row should be generated in the store table. Okay, I have 44 rows today in this particular table. But tomorrow there is no new store will be generated quickly in a single day. That's why that particular dimension table is not changing daily basis. Even the change rate is very low. Okay. But the fact table, it's changing per second. Okay. It's having transactional data. In each second, there is a sale in particular outlet. Okay. So this sale information is being stored in fact table. So dimension is very slowly changing. I'll be coming what is slowly changing dimensions and all quickly. But to comparing with fact table and dimension table are very slow in nature. Even the row numbers are also very low comparatively to fact. Fact is highly changing table. Okay, I think you can get idea. So sales, what are the prices? Each of the transaction made, each people bought something over there. Each transaction, they are having each transaction. So each transaction are being stored in sales table. Okay. Now I'll be coming quickly with again with fact and dimension by when we'll be creating the data modeling and all. Now some few features we need to tell you about fact and dimension. So what are those things and all? Let me quickly continue. So there are two topics called grain and granularity. Okay. So grain, what is grain actually? Grain is the business definition of a fact table row. A particular row of the fact table signifies what is the thing that is called grain. Okay, so maybe when you are working in the data engineering and you have the responsibility to create the fact, that time your business owner or the BT, business technical person, they can tell you that what should be the grain of this fact table. By checking that grain, you have to create the fact table columns. Okay, so what is the thing? Let me show you. So suppose this is a fact table. Okay, we have sale ID, bill number, date, item code, store ID, quantity, amount. You can see those are the fact information only. The other five thing are primary key and foreign key. This is primary key, sale ID, and those are the all foreign key. Okay, so what is the grain of this table? It's mentioned over here. Sales transaction per item in a bill. So sales transaction per item in a bill. Sales transactions mean sales transaction obviously in a particular outlet code. What is the transaction amount? It's very low level transaction. We'll be coming to granularity quickly. Then I'll be telling you what is low level and high level. Grain and granularity. Now we are learning grain. A particular row signifies what thing for the fact table. Let's take the next example. Here is the table. It's a fact table, obviously, and it's mentioned as marks of a student got in a subject in an exam. Okay, marks of a student in a subject, marks of a student in a subject in an exam. So exam level is also differentiated. That's why it's in an exam. Okay. Okay, let's go ahead. What is granularity? Granularity means how atomic level we are determining the fact rows. Okay, how detailed level we are taking it. So if we are putting the thing in a very atomic way, we are any minute transactions thing we are putting it over there, then it is calling atomic level data. And if there is low granularity, this is for high granular. That means we are putting everything over there. Just like let me give you an example for this one. Okay. So if I just aggregate the things, uh, okay, let's omit the subject column over here. If I omit the subject column, then that two row will be merged as per the normalization process. 2003 9B finals Aryan Dev and okay, not yeah, this two will be merged and their marks should be 50 plus 98 and the aggregated marks should be there for the single row. Okay, but this is also a fact table, but we can say this is less granular than that of this one. Okay, if I also omit exam name from there, then this row will also be merged. Okay, so exam name should not be there. Rather, the grain should be also modified. That should be marks of a student for an exam. That should not be also there. Marks of a student in a particular year. This should be the grain that time. The three row will be merged. Okay. So based on introducing a particular column or based on changing a particular grain as well, the granularity depends on it. How much granular level we are capturing the data in fact table. If the column name is increased over there in the table, the much granular it will be. That thing can also be granular more. Suppose we are taking the question marks over here. Suppose broad question, short question. If I just put this two columns again, then this mark should be also differentiated. I mean, it should be also splitted. Okay, but that much minute level, it's not very helpful for the principal to check in this many line items and all. So this is sufficient for a particular student. So uh, as per the product owner should be taking the decision how should be the fact tables grain and granularity. So here product owner should be a principal or maybe class teacher or just like this. So they will be telling the IT candidate or IT student that they need the result or they need the analysis in this format. After that, they can check each of the students' performance and they can take further decision to improve their performance, or they can or principal can help to appoint some more class teacher in a particular class if the entire class's performance is low or just like this. Okay. So grain and granularity is the thing clear to you? It's very simple. Please tell me if there is any doubt. Okay. I think no doubt there. So granular means, how much granular or how much line items we are capturing to signify a particular row. Okay. So that thing, grain and granularity, those things should be coming while designing the fact table. Okay. But this is the, maybe if you are facing some interview, they can ask what is grain, what is granularity. Those are the terminology actually. Those terminology we need to know to work further. Okay. Now the next topic is SCD. It's called slowly changing dimension. It's about dimension that I already told you. Dimension is being stored in a dimension table with very less frequency. So the change is there may be a country dimensions are there. Okay, just let me give you an example. Country dimension. So it is storing all the countries dimension. In the dimension table, we can see the country's name, country's ID, their latitude, longitude information, or maybe their neighboring country. Maybe for a particular year, a new country has not been introduced in the world. Okay, then how country dimension can be modified? So it's very, dimension is not changing second or daily basis or say yearly basis as well. Dimensions are very it's changing in very low in frequency. Okay, but fact is changing in transactional level. whatever transaction, sales, billing is being done for daily basis, that can be captured over there. Okay, so while storing the data of dimension, we are taking into consideration, I mean, it's called slowly changing dimension, SCD. So any of the format we can take into consideration while loading that dimension data. So what are the thing I have an Excel to show you. Sorry for my bad, I think I have stored something, it was not there. Okay, it's there. Okay, let me do something. So let's learn SCD type 1, how the data can be stored. This phase, okay. I just put this thing as example. So we have an employee table, employee for a particular organization. Okay. So this, how we can be stored it. So employee ID, employee name, and the particular employee's designation. So this can be a simple employee table. Now, if we are loading in the very next day of SCD type 1 table, employee table, as I told, particular employee table can be refreshed. I mean, it should be refreshed. Yeah, it can be always refreshed, but the data cannot be modified daily basis. But it can be modified as well. Okay, but the frequency of change should be very less. But whatever change we are seeing over here, just like what changes we can see over here, ABC, BCD. Okay, ABC. I mean, it is yesterday's record. Yesterday the table instance was this, but today when I'm just after refreshing of data for today's job, okay, there are ETL job to refresh the tables that I told you earlier. Each day ETL job runs and our tables data got refreshed. So maybe the source system data, we are capturing some bank related information. So whatever data has been captured for the entire previous day, that means the credit sales information and all. So those are being captured into the very next day or maybe the end of the day to this dashboard or to the fact table and dimension table. And that process can be done by ETL job. There are job, there may be batch schedulers and all. So they have been scheduled a particular time. So when that particular job should run, it will store the data from source system to target. So target, we have already tables, the tables are existed. So there may be lots of loading strategy. I'll be coming to this point quickly. So for each of the loading strategy, they can load the new data from the source system to this target data mart table. Okay. So suppose we have the change, what was there for yesterday's data. We have a small change. Just like for the first row, you can see employee's designation has been updated to developer. It, he was trainee. So as per the company policy, for first 6 months, the particular user can be told as trainee or particular employee can be told as trainee. And the same thing, he has been designated to developer. Okay. And one more row we can see, a new customer has been added as trainee. A new employee has been added as trainee. Okay. So those are the two change we can see over here. Now the question is, that is fine. If we are just adding the new thing, it's fine. The existing. So this is the way of loading of SCD type 1. We cannot check the history. We cannot check this value anymore. Okay. Suppose for one, ABC joined the company as a trainee or developer. Maybe he has come from another company as a developer role. That thing we cannot convey or cannot determine by SCD type 1 methodology. We are not storing any historical information. That is the reason. So we cannot check the history of ABC employee, whether he has joined, whether he or she has been joined into the company as a developer role or trainee role. Okay, maybe he has joined from with trainee and later designated with developer. That can be one scenario. Otherwise, the employee has directly been joined in the company into developer position. Okay, so this kind of issue we can see in the SE type 1, but it's very simple to design, very less thing to uh, incorporate over here. Okay, we have another method called SCD type 2 to eliminate this storing of historical information. So there you are introducing some date column. You can see. So SC type 1, I think it's clear. It's very simple table where we are not getting any historical information. Now SCD type 2, what is it? So we are having employee ID, employee name, employee designation. With the employee designation, we have an extra column called date, or that is the proposed date, or just like this, in which date that changing is there. So trainee for the particular which date the particular user has been designated as trainee. Those are the important thing we have been stored in date format. Okay, trainee, account manager, developer, senior developer. So for which particular date they have been designated into this position, you can see over here. So it was yesterday's record. Today the data has been loaded to the table. Okay. So you can see now employee ID is not a primary key over here. You can see it's been duplicated. So the combination of employee ID or any other thing will be the primary key. Okay, anyone is telling anything? Okay, I think it's simple noise. Okay, no issue. So uh, when we received today's data, you can see ABC was trainee for 23rd Jan, and after 1 year later, he has been designated to, it was 24th Jan again, 2023. You can see the data. So he has been designated to developer position from trainee to developer. So over there in this table, by simply introducing a particular column, we can determine what is the date. Which particular date the particular employee has been designated. Okay. So those things can easily learn or easily visible from here. This is called SCD type 2. This kind of loading methodology or strategy is called SCD type 2. It's a bit complicated while designing at the ETL side. We are loading every data, but this kind of logic we need to implement it in the ETL process so that they can load it accurately in this manner. Okay. Now, what is SCD type 3? This is the last one we can follow. There is various SCD as well, but as the normal convention in our project or daily basis, project we are working in the companies and all, we are generally following any of the three way to store our data. SCD type 1, type 2, type 3. Those are the main, the common thing we can say. But those are very much important. If you are just going to face any interview, they can tell you what is SCD type 1, SCD type 2, type 3. They can give you the scenario, what is the thing they will be telling to you. Just you have to clear your concept, why those things have been used. What is SCD? It's slowly changing dimension. How is the strategy to load it? So there is three strategy over here. Primarily there are three strategies, but there are some extras as well. SCD type 4, type 5 is also there. What I can assume, but those are not been used. Those are just theoretical purpose. They can put it over there. Okay, fine. So type 3, this thing should be at the bottom. Okay, let me just put this thing over here. This thing, okay, that's correct. This thing should be at the bottom. Earlier there should be this data. Okay. So suppose we have the information. Okay. So maybe it's a date of joining or just like this, or date of last transition. Okay. Last transition we can tell. So over there we are not introducing one more line items over there. Rather we are introducing one more columns just like previous designation. Okay. So if anything has been updated recently, the last date when it was been updated and what is its previous designation. Okay, so we are introducing a extra column, rather introducing over here a extra row. Over there in SE type 2, we are introducing a particular row to have some the historical information of each of the employees. But over here, we are introducing an extra column to get this information. Okay, so those are the concept of three SED type: SED type 1, type 2, type 3. Any doubt from anyone to understand the SED type logic? Nothing. You can interact if there is anything, any doubt or any stuck point. There'll be no issue to ask because this is a bit complex. What is SCD and all, but you can understand this is not. I mean, very much hard, but a bit complex. What we are learning till beginning. Okay, so hopefully that is understandable. Now, if we just can remember our fact and dimension table, our fact and dimension is ready. Okay, our fact and dimension is ready in nature. Then before visualizing that part or before taking that part, we have to follow the data model. Otherwise, we cannot set up relationship. So suppose maybe if we had to uh, in particular transaction level, we are storing the data in fact, but in fact, we need to combine with dimension as well. Suppose a particular business owner, they need to check for a particular employee what he bought from the market. Only in the fact table we can see the particular MRP, discount, product ID, not the product name. So to get the product name, what particular product the particular customer has been bought, over here the customer ID should be there. No customer name should be there as well. So we have to join first customer information with fact information to get the customer name for that particular customer code, customer key, rather I can say customer key, customer key. We can get the customer name. Then based on that customer, what he has bought that particular day, will have to join with product key with product table. Okay. Then we can fetch all the product related information, product name as well. No, I mean, there is no helpful to check the product key only. So rather, we can get all the product name from joining with product key. Okay, so this is called data modeling. That thing is, I mean, we are setting up relationship between fact table and dimension table. That's all, data modeling. One or two more things we need to, there'll be I mean, a matter over there. We need to pass some cardinality for one each of the fact. If there is multiple, I mean, one to one or one to many, this kind of relationship we need to set over here. Okay, so this thing will be learning later. I mean, it's a bit complex, especially when we'll be designing. Uh, Especially, it should be a snowflake schema. So, what is star schema and snowflake schema? I'll be coming, and those are the very much important questions from the interviewer as well. What is star schema and snowflake schema? So, here schema is not the same schema what we have learned in the database side. Okay, in database we are storing the data in separate schema. That is fine. But over here, schema is a different thing. What is it? Okay, there are two kind of schema we can see over there. One is star schema. Star schema, I mean, it's a joining methodology with the fact table and dimension table. If we have only one single fact at the middle and the dimensions are surrounding it, just like this one. So it's called star schema. It looks like star. We have sales over here at the middle, and those are all dimension: store dimension, time dimension, customer dimension, product dimension, payment type dimension. Okay, we have single fact table over here and 5 dimension tables over here. Okay, we are joining, we are setting up relationships by this line. Means based on a particular common column, we can join the data and fetch all the dimensional information into fact table. Okay, to represent the thing in front of customer. As we told that we have discussed in fact and dimension, we are making this thing in normalized in nature. What is normalization and all we have covered in the second class. So there should not be any partial dependency. The rows should not be duplicated in nature. So that's why we need to maintain the keys over here. Rather, we are not putting product name. We are putting product key. As there are product dimension table, there is a different table called product dimension. So there we are also declaring product key versus product name. So by joining between product key with the fact table and this dimension table, we can get product related information there. But in fact, we cannot store product name. So this is not a good practice. That's why we will be only storing keys value in fact and the fact data. That is the measures value. Keys means it should be primary key and the foreign key of other tables and the fact related informations and all. Okay. Any doubt? This is called star schema. Now let me move ahead with snowflake schema. Let me show you the diagram. So snowflake schema, it's not directly, it's just like in star, you can see fact can be joined with dimension. Dimension cannot be splitted further. But in snowflake, I mean, you can see that the particular dimension has been splitted further from this point of view. Product, then on top of product, there is brand table. Brand table is not directly touching over here. It's just splitting the product to brand. Maybe there are brand ID available in the product as well, or maybe it's vice versa. In brand, there should be a product ID. So based on the common one, we are joining. So over there, category ID is there. So it's been the particular tables have been created from another dimension. It's been joined with another dimension. The other things are fine. Geography, customer, organization, time, it just looks like star schema, but all the dimensions are not directly have a relation with fact. Rather, it is having relation with other dimension. So this is called snowflake schema, and in practical, we should be facing this one because star schema is very simple one. If we have very simple methodology or very simple table structure, then it should be fine to design snowflake, I mean star schema. It's very simple to implement. But in our practical scenario, we can see most of the things should be snowflake in nature because we should not be setting all the relationship with fact. Rather, we can set some relationships of dimension with other dimensions as well. Okay. So that thing we just need to keep in mind. What is snowflake schema? What is star schema? And when those are required. So that thing can be definitely asked by interviewers. Okay, this question is very much important. Okay, okay. Now we have covered, I mean, this is the data modeling part we have learned. So data modeling should be helpful to design the charts, graphs, or maybe the data scientist can directly fetch the data from the data modeling and all. So the data model is very much important. Even by checking the data model itself, we are going to create fact and dimension. Data model should be creating first. After checking the data model, we can create the fact and dimensions table definition, DDL. Okay, so what column we need to introduce? What should be the primary key naming convention? should we include one more primary key or foreign key over there? So these kind of questions we can see from this data model design. Even while creating this data model, it's a bit complex. We need to check a lot what particular columns we need to introduce and all. So when data modeling is ready, most of the works has been done. By checking the data model, we can easily create fact and dimension table. Okay, now what is ETL? That kind of thing we have mentioned it on previous day at lots of time, even today as well. While loading the data from source system to target, we are using the ETL tool. So ETL means extract, E for extract, T for transform, L for load. So extract means extracting the data from the source system. So source system, there may be various source system in nature. So just like if we are just considering the database files, I mean database and all. So there are various databases like MySQL, just like Teradata, just like MS SQL Server. It's Microsoft tool, Microsoft SQL Server. There are Oracle, and Sybase. It's for SAP. SAP HANA is there. Lots of things actually. We cannot finish it. I mean, today nowadays, I mean, lots of database has been introduced, and those are being used as a OLTP system. And we are pulling the data from that source system. That is called extracting the data. ETL. We are extracting the data from the source system. We are transforming it inside the ETL. Transforming means if we just need to check the data integrity or data accuracy, maybe there are trial spaces been added for each of the row and all. So we need to remove those I mean, that particular characters and all. For date format, we need to check whether we are having correct date format or no. So those kind of stuff we need to check by ETL. I mean, by the transformation. Then at the last topic is load. It should be loading the same data, the transform data into the target system. It's the data warehouse, enterprise data warehouse. Okay. So daily basis, the jobs are being run. It's not daily. If it is an important one, important database at the target system, it should be running hourly basis. Based on the transactional refresh at the source system, we can design the ETL refresh as well. And based on the criticality of the data, it also depends too. So how much critical is data? I mean, how much way we have to refresh the data with this from the source system itself, that needs to be checked, and the same way we need to push the data at the target side, the transformed one. Target means the data warehouse, source means the source system from where we'll be receiving the data, OLTP. Okay, so ETL does the entire thing over here and storing it to here. Now what are the different data extracting method? Data extracting method, how are the methods that we can segregate the data extracting? When designing the ETL, we need to take in mind what should be the approach. Maybe it's a full refresh, maybe it can be incremental refresh. As for the naming convention, I think you can understand the thing. Full refresh means we will not be checking whatever data we have received from yesterday. We should not be checking that one. We just refresh all the data what is there in the source system, and we can push it to target. We can extract the all the information. But what is incremental? This is the smarter way. In the source system, there can be a date or timestamp column should be there. Okay. I mean, when the particular rows has been introduced into the table, so that thing can be captured in a particular table. So why this is required? Why the date time is required? When we will be running our jobs in our ETL, there should be another timestamp. Okay, so when we are fetching the data from the source system, we can match the timestamp with the timestamp column available at that table. Okay, just we need to capture what is the maximum timestamp till what the time we have loaded the data from the source system. So we can compare this data with ETL date. I mean, the date from the maximum date that I have loaded today's data. Okay, so we can store this information somewhere in ETL. So when the next day ETL will run, it will not extract full data, rather it will be checking by this date field what are the new column or new rows we have received for today's job to load. Okay, it will not extract the full data again, rather it will be checking what are the incremented, means the new records has been received at the source system, and it will only load that extra part. Okay, so this is the smarter way nowadays. uh, I mean, we can use that thing as well. Incremental should be fostered in a way because we are not loading all the rows, but there are some design methodology or something is different for each of the table loading strategy. That's why full refresh can also be taken place. Anything we can do. Okay, full refresh or incremental data loading. Not a data loading exactly, it's data extracting. Data loading I'll be coming. Yeah, it's data loading. So insert, and I mean there are three, I mean those are the main three concept of data loading strategy. The first one is truncate and load. That means if we are just going ahead with the full refresh, that is the one. Then we need to truncate the table, the target table. Okay, because if we are not, I mean we are extracting all the data from the table, not the incremental one. The same data needs to be pushed at the target. We do not have to matter what are the data has been available already in the previous day. That should not be a matter with us. Rather, you can directly clean all the data and push it to there. So that is called truncate load. Truncate the table and load the table. And there are few more things. Insert. So this is mainly for incremental load or maybe full extract as well. We are extracting everything from the source system. We will be comparing with the target. What are the new records? The new records will be inserted only or appended. Anything we can tell. Insert or append. Okay. So let me repeat once more time. It is, I mean, the second insert is a uh, loading strategy where we can get the extra set of records and push the same into the target. There is another one, and the most efficient one in nowadays, we can say it's update and insert. So we are loading in an incremental way. We are checking what are the new records. That is fine. Maybe there is something that some columns primary key is same, but other data has been modified. Just like the example we are seeing in ACD type 1 or type 2, rather, I can say, or maybe this one. Okay, so for type 1 and type 2, okay, for this one, suppose yesterday we are having this many records. Today, what is modification? We received one new record, and this record has been updated. This field has been updated. Those are the two new things we have received from the source system. So we are loading it as a upsert method, that is called update and insert. In short form, we can say it's upsert. So what is the methodology? It will be checking what are the new records based on the primary key. So the new record should be appended or insert, anything. So this is the new record. This has been inserted into this table. Okay. And the old record, it will be checking the old records based on the primary key whether any attributes has been modified. So it can see the primary key 1 employee designation has been updated. So it will not be creating this one over here again. Rather, it will be updating the record. Upsert, that is called upsert. Update the old record if there is any modification in attributes. Okay, or and if there is a new record, then it will be inserting it. So that is the update and insert methodology. Okay, Where was I? Yeah. So, any doubt? Any doubt from anyone till now? Nothing? Okay. So, those are the data loading strategy. Now, as we told you that there are various tools available. Those are called ETL tools. That is storing the data. That is, we can put the logic of upsert, append, truncate load. We can clean the data. We can do the normalization process. We can follow such a way that the normalization can be occurred. We can do lots of aggregation functions and all. Those are called ETL tool. So there are lots of tools available in the market to do this ETL operation, extract, transform, load. And this is one of the basic thing for a data engineer to learn one of the ETL tool. So there's lots of product vendor just like Informatica. Those are the product vendor and those are the candidate products. What we need to learn or what is being used while doing the ETL process. So just like Informatica, this Power Center, IBM Data Stage, Ab Initio is there. For SAP, this is one. Cognos Decision Stream or Cognos Data Manager I have also found earlier project. For Microsoft, there is SSIS. It is also SQL Server Data Transformation Services is there. Oracle Warehouse Builder. So those are all important thing what by which you can do the ETL operation. But nowadays, those are the licensed product we need to buy from the market. Nowadays, the product owner they are determining some open source languages and they're creating some framework. Just like we'll be learning Python. So by using Python language itself, they can load the data from source to target with transforming and all. So it should be very cheaper in rate because we are not purchasing any licensed product tool. Rather, we have designed some framework there using an open source language that is called Python or Java, anything. And based on that, we are loading the data or refreshing the data daily basis. So over here, Python language should be working as ETL tool. Okay, so we'll be learning Python language as a ETL tool soon. Maybe tomorrow onwards we'll be learning Python. The first 2 3 days it should be basic, and after that we'll be using Python as a data engineer perspective. And the very last day we'll be learning how Python can be used as a ETL tool. Okay, okay. Now I'm just going to the dashboard part quickly. So our data model is ready. Our data mart is ready. So now the dashboard team, they can pick the record and they can create the dashboards. They can create their charts, graphs, and they can present the same thing in front of business owner. Okay. So it's a point from their perspective, the visualization in engineer's perspective from the latest 6 or 7 slides have been designed for them, but they are also been included in data engineer, but they are not directly handling the data load and all. Rather we can say they are taking data from the data warehouse and building the dashboard. They are doing some analytical operation as well, but at the end they're building the dashboard which having multiple charts and graphs. Okay, so the first topic it's called key performance indicator. In short, we can call it KPI. So KPI is terminology we can say. Suppose we need to, I am a visualization engineer. I need to reach out to product owner for which kind of charts and graphs he will require at the dashboard. So they will be telling the KPI. They will not telling everything that you need to create. Uh, Suppose in x-axis it should be sales, or rather I can say in y-axis it should be sales, in x-axis it should be year. So you can create a line chart between sales and year. So not this kind of thing, rather they can mention it's a KPI. So they will be telling us create a line chart and create the lines at such a way so that we can understand the sales transaction per year. So over here, KPI should be sales transaction per year. A single sentence or single phrase which can explain what is the basic thing of that charts. So similar thing that's like what we have learned in grain. Grain to describe the fact table. The same thing KPI should be describing the quantitative or qualitative indicators which would be helping for improving performance for the business. So they'll be telling this thing, and it's a metric and we need to design the same thing such a way. So just like over here, there are quantitative KPIs just like sales growth, quarterly revenue. We need to design the charts and graphs such a way so that that can be easily visible. And there may be various graphs for a single KPI determinations and all. But you need to choose any one, or maybe you can take the decision with discussing with the product owner or the technical one. Similar thing is there for qualitative KPI. There are customer satisfaction, product quality, service quality. So those are the KPIs we can show in the dashboard. Those are not quantitative, rather we can say it's qualitative. Okay. Okay. So I just put some simple charts and graphs, how it looks like. It's a bar chart over there. We can see multiple dimensions are put in x-axis and a single fact is being represented at the y-axis. It's revenue fact. And what are the dimension? Zone is a dimension. So east zone, north zone, south zone, east, west zone. This is a dimension. And there is also dimension of ER. We can see in x-axis there are two things we are representing. Those are two dimension. One is zone, one is year. Okay. And in y-axis it's only revenue we are describing. There are various based on the requirement. Maybe we need for two facts, two dimensions to be represented in a chart. What kind of chart I need to pick? There are lots of charts available, visualization technique available. Based on the requirement of us, how many dimensions, how many facts we need to show, or maybe it may be in other scenario, what should be the thing, or maybe the volume of the data. Based on everything, we need to determine what charts or graphs we'll be using to showcase our data or to analyze the data. Okay. So there is a structure that is called pivot as well. I'm just putting some important topic over there of representing the data. Over the last topic, we have learned the bar chart. Over here, we can see the pivot table. Pivoting the data means we can transpose the thing. Based on which is the requirement, we can pick some rows and columns, and that can be over there. This is the, each of the columns is been represented by each of the year. And in this column, we are having only city. Okay. The same thing, we can pivot it, we can transpose it, we can see it has been modified in this way, and the data will be impacted as well. The data should be moved. Data means this data, this value can be moved as well. Okay. Based on the combination of, suppose we are having the year and city combination 2009 and Mumbai. The first cell is fine, it is representing both of the thing. But the second one, suppose it is 2010 and Mumbai. Over there I can get it in here, and here we're getting it here. It's simpler transpose kind of stuffs over here. We can say transpose of a matrix. It's this. Okay. Moving to the next chapter or next slide. So there is some terminology called slice and dice. Over there, we are visualizing the thing with two dimension, one fact again, but it's 3D graph. Okay. What is slice? We are slicing the data by selecting a filter of 2009 as a year. Okay, we can see only the front thing should be coming, the blue one, because we have selected 2009 as a year to represent the data. So this is called slicing of the data. Slice. What is dice? If we just select multiple filters, filters from the multiple dimensions. Okay, we have selected filter for year in 2009 and 10, and for the city we have chosen Mumbai, Delhi, Kolkata. So after choosing this, we can see it's dicing. So it's called dice. Slice is the previous one by selecting only one. Dice is representation of multiple or the filter choosing on multiple subject areas. This is called dice. Okay. There is another approach what is called roll up, drill down. Okay. This is a totally opposite word. So in this example, you can see it's a drill down approach. Just like there is some method over there, we can declare the dimension in such a way. I mean, it should be declared in hierarchical in manner. So we have to declare year, quarter, month, such a way so that if we are creating this thing, if I'm double clicking on top of 2013, it can be splitted into its next hierarchical value. It should be quarter one, 2013, quarter one, quarter two, quarter three, quarter four. Now, if I double click on each of the quarter, then it can be splitted into multiple months. So this kind of dimension we need to design earlier. This is called hierarchical dimension, and that hierarchical dimensions we can put into this copy so that when we can double click it, it will be drilling down. That is called drill down. The same thing has been represented in graph format as well. At the right hand side, we can see we have double clicked on 2013, then it has been drilled down to 2013 quarter. There are 4 quarters. Now, yeah, if I just want to go ahead with third quarter, okay, double click on this quarter, then it has been splitted again with July, August, September data. Okay, so it is called drill down. The same thing can be called roll up if we just go ahead from this thing to this thing to this thing. Just like the opposite thing, vice versa. So, roll up means from extra granular level to low granular level. This is the thing. Okay. So, this is called roll up and drill down. Okay. So, those are the all topic we just learned for today. I think we have already covered up the session timing as well. So, this is called business intelligence. And in business intelligence, you can see there are two kinds of roles are there. One is, I mean, all the things are called data engineers, that is fine. But inside the data engineers, I mean, it's some people worked on DDA, I mean, data team. Data team means they can work till data warehouse, data loading. They can work in ETL. Okay. A few of the data engineers can work as a visualization team, visualization engineer. So maybe if I think you are freshers in nature, maybe you will be joining in the company, then you have some knowledge on the ETL tools and all. After that, someone of you can then check, someone of you are quite interested in learning visualization tool rather ETL tool. So it's totally as per their wish and as per their choice. And maybe you can, if you are working in a ETL tool, then you just have to focus only one or two ETL tools, so that when you are bit experienced for one ETL tool, then you will be trying to have same kind of expertise of the same kind of ETL tool and go ahead with show the same thing. I mean, go ahead with your, I mean, skill showing in the as the same expertise level of the ETL tool. If you are working as a visualization team, then there are lots of visualization tools are available that I told you earlier. That is Tableau. There is Power BI from Microsoft. There is Cognos. There is Click. So those are all tool. Any one thing you can learn and you can have your expertise and go ahead and switching the company with that expertise. You can have the cross thing as well. You can learn both of the things, especially the data architect and all they have the knowledge of both data and the visualization thing. They have to coordinate between multiple teams and all. Okay, so they need to know the knowledge for both of the things and all. They have to check the entire picture from checking from the top level. So this is the thing. Actually, when we'll be learning, when we'll be entering in a company, we cannot see the overall thing from source to target and the design thing. But as a business associate who are doing the MBAs and joining the company, they are telling the KPIs and all. Maybe the decision owner, they can check the end data. They will not check the ETL data, what we are doing the ETL side, the ETL logics and all. So each of us should be having our own set of work. We cannot see everything in a combined way. But when we have some expertise or we have the knowledge, then we can quickly understand what we are doing, what is the end result. We can coordinate between teams to check their data as well. So the product owner, they are checking everything from the top level. They are checking the entire structural pipeline. So from which source system it's coming, how the data, just like some structural pipeline or flowchart we have shown you earlier yesterday. Flowchart was there. So same kind of things architect can visualize by the flowchart and all. Okay, but as of now, as a beginner, you can just start or go ahead your career with taking one of the thing, pick up one of the thing and learn the thing and have some expertise on that one. But as a fresher, you have to join as an entire data engineer. You have to learn everything in a very minimal way so that you can answer the questions of interview and you have the idea to crack it or you have the idea to do it by your own. But when you will be a bit expertise 1 or 2 years, you can choose any one of the technology that you are working and just go ahead and show your expertise level with any other company and get recruited there as well. Okay, so this is the concept, I fundamental things I want to convey over here. Okay, so those are called business intelligence, what we have covered. So tomorrow onwards, we'll be learning Python for the entire next week or maybe 1 or 2 days extra. First 1 or 2 days, it should be totally Python basics. We'll be learning the basics, data types and all, but those are very much important. Okay. And on after that, we'll be learning how we can use Python as a data engineer tool. Okay. Gradually, we'll be learning those things one by one for the entire next week. Any doubt what we have learned for today? Anything from your side? Nothing? Okay, let's connect then tomorrow. If there is any doubt, please ask me. Thank you, everyone. Bye bye.